combination. So permutation is selections of members of a set with order. So order matters. So permutation of combination of 1, 2, 3. So 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So you can see the order matters. So permutations are used in almost every branch of mathematics and many fields of science. In computer science, they're used for analyzing and sorting sorting algorithms. In quantum physics, they're used for describing the state of particles. Biology, therefore, sequences, RNA sequences.
What's an RNA sequence?
It doesn't matter. So the number of permutations of n distinct objects is n factorial. So you should recognize the n exclamation mark, so n factorial. For the case n objects, so for you pick k ordered elements. So the permutation, the formula is n factorial divided by n minus k factorial. And you might want to know that 0 factorial equals 1. Define that. So combination. Combination is a selection of members of a set, and order doesn't matter. As long as all of these are in the set, then order doesn't matter. So for the combination formula, it is n factorial divided by r factorial times n minus r factorial. Okay. So you can see the difference between permutation and combination. Permutation order matters. So you have all of these numbers listed out in different orders. But combination is just any order is fine. It's just the objects. So an example, how many words can be made up from RAs, SBs, and TCs? So let n equal R plus S plus T. So if we assume all of the A's and A's, B's, and C's are different, then there are n factorial words. But the A's are not distinct. So n factorial words occur in groups of r factorial words, which are the same. So then that means it's n factorial divided by r factorial's words where the A's are not distinct. And then again, the B's are the same. So the words occurring in the group of s factorial, which are the same. So there are n factorial divided by r factorial times s factorial words. And finally, C's are also not distinct. So we have n factorial divided by r factorial times s factorial times t factorial, different words. So how many subsets of size 4 can be chosen from a set of size 6? So this is a combination problem. So order doesn't matter. So where n equals 6 and r equals 4, the number of subsets equals n factorial divided by r factorial times n minus r factorial. So this is 6 factorial divided by 4 factorial times 2 factorial, and that's 15. So black and white ball. So in a box there are black and white balls. Picking 12 balls, how many ways are there picking the colors? So the ones represent the balls, and each one before the zero represents a white ball, and each one after the zero represents a black ball. So these are all black balls, and this is a white ball, this thing. So you can see that combination is just 13. There are 13 ways you can pick the colors, because you're only moving the 0 1. You can just move the 0 1 um, to the right every time, and you'll get 13. So the theorems will be covered later, like these binomial theorem, etc. And yeah, I'm done.